The problem is, the Earth, mass, and spring are all in the same system. In this lab the spring moves in an arch instead of straight up and down. I will map the movement of the mass and compare it to the movement in the Python system. I was able to gather the data by using the tracker software. I used the data to make a graph. This data was then copied into a CSV file that will be used in the Python code. The initial conditions are all set to the correct values, which can be seen in the upcoming clips. The yellow ball is the mass in the original video. The yellow line is the movements the ball makes. The blue ball is the way the physics says the ball should move, which is the exact way the yellow ball moves. The graph shows that they have the same movement. Here, I show the change in the potential energy of the spring constant. This is different from the at lab, because spring is in the system. So the change of potential energy of the spring was compared to the change of energy of the system. The potential energy of the spring is 1/2 times Th. So what does this mean? How did I find the oscillation? Well, I found that the frequency, which is the difference between two arches. Then I took the inverse of the frequency in order to find the oscillation. I found that the oscillation of the x component is 0.6172, and the y component is 0.6535. Since the system now contains the spring, then the work by the surrounds on the system is 0. The only thing not in the system is the wall the spring is attached to, but this does no work because it does not move. The third question wants y equals 0 to be the origin. To do this I subtracted -0.7 from the y position of the initial spring position and the initial mass position. With this new origin, everything has been translated up 0.7. This does not change the physics at all. There was no change in t. The main result, we were able to find that work equals 0, so the change in energy equals 0. We found out how to find the oscillations, and we found out that the x and y component were different because they depend on different variables. The x component depends on the length divided by the gr. The x component depends on the length divided by the gravity, while the y component depends on the mass divided by the spring stiffness. Also, the new origin is just the old graph translated 0.7 up. This is the conclusion of Lab 9.